on October 19, 1990. University of Tokyo Hospital admitted a patient who had just been exposed to radiation 20,000 times the annual upper limit for ordinary people. The patient was conscious, showed no burn marks, and appeared almost normal except for a slight redness on his right hand. The nurses in charge thought he would be discharged soon. But just one day later, his skin turned red like a sunburn, and his right hand began to swell and ache. At this point, the patient didn't know that at the moment of excessive radiation exposure, the chromosomes storing and transmitting genetic information in his body had been destroyed. This meant his body could no longer produce new cells. A week later, nurses found that when changing medical tape, the skin in contact with the tape was torn off without exception. Normally, skin renews itself constantly. The basal layer continuously supplies new skin cells to the upper layer. But his old skin kept peeling while new skin couldn't regenerate, causing his entire body to gradually ulcerate. There was no healthy area left. Worse still, the white blood cells responsible for fighting pathogens in his body had almost vanished, making even a minor infection life-threatening. Meanwhile, his lungs began to fill with fluid, making breathing difficult. After doctors decided to insert a ventilator, he could no longer talk to his family. 27 days later, a colonoscopy showed his intestinal mucosa shedding in patches with diarrhea increasing daily, exceeding 3 liters per day. 3 weeks after the diarrhea started, his intestines began to bleed profusely, sometimes requiring more than a dozen blood transfusions in the morning. The body fluids oozing from his skin and intestines reached nearly 10 liters daily. He repeatedly asked doctors to stop treatment and end his life, but could only watch his body gradually break down and melt, enduring unimaginable suffering. After 83 days of treatment and agony, his life ended just before the millennium. The patient's name was Hishiauchi, and he suffered from horrific acute radiation sickness. Some students might wonder if it's a less acute radiation sickness caused by nuclear radiation, would the situation be better? The answer is yes. With luck, it might only cause damage to the nervous system, hematopoietic system, immune system, reproductive system, cancer, and other issues. What's clear is that once exposed to excessive radiation, the damage to the body is undeniable. So here's the question: how exactly does nuclear radiation harm the human body? Nuclear radiation, as the name suggests, refers to the emission of particles from an atomic nuclei. The emitted substances mainly include alpha rays, beta rays, and gamma rays with significantly different destructive power. Alpha rays are high-speed helium nuclei akin to arrows. They have the weakest penetrating power. Even a sheet of paper can block them. However, if inhaled into the body, the danger escalates dramatically. Beta rays are electron streams similar to handgun bullets. They can penetrate the skin, causing obvious burns, and require aluminum plates or protective suits for defense. Gamma rays are high-energy electromagnetic waves like sniper bullets. They can penetrate the human body and buildings, necessitating lead plates or thick concrete walls for shielding. All 3 types are ionizing radiation, which damages cellular DNA and other biological macromolecules through ionization, leading to abnormal cell function, death, or cancer, thereby causing various bodily injuries. When does nuclear radiation occur? When nuclei are unstable. Some elements are inherently unstable, such as radium-radon in soil and building materials and polonium-210 in cigarette. Alternatively, instability can be induced artificially, for example, bombarding uranium-235 with neutrons. This causes uranium-235 to split into lighter nuclei, releasing multiple neutrons and massive energy, a process called nuclear fission. If nearby uranium-235 nuclei exist, released neutrons trigger continuous fission, forming a chain reaction. Uranium-235 with 3 to 5% enrichment is used as nuclear fuel. Uranium-235 with over 85% enrichment is used in nuclear weapons. Neutron radiation from nuclear reactions is extremely penetrating and destructive. Hishiauchi was exposed to lethal neutron radiation because he and colleagues illegally added excessive uranium to a precipitation tank during nuclear fuel preparation, causing uranium-235 to exceed its critical mass and initiate a chain fission reaction. After mastering these fundamentals, we will explore humanity's largest campaign against nuclear radiation and learn methods to cope with it, knowledge we hope to never need. According to the International Nuclear Event Scale, the criticality accident that happened to Yashiyashi was classified as level 4. That's because level 4 is as high as it goes for that incident. The Chernobyl nuclear power plant accident, on the other hand, was rated level 7 since 7 is the highest possible level. On April 26, 1986 at 1:23 local time, reactor 4 at the Chernobyl nuclear power plant in Ukraine exploded. Lethal doses of radioactive particles shot into the sky and spread with the wind. Experts estimate the radiation released was over 400 times that of the Hiroshima atomic bomb. At that moment, the roof of the adjacent reactor 3 was on fire. If the fire wasn't put out quickly, the consequences would have been unthinkable. At 1:28, the first group of firefighters arrived at the explosion site to fight the blaze. Radiation levels in some areas exceeded 10,000 Rho, and to put that in perspective, exposure to 10 roentgens in an hour significantly increases cancer risk. Getting 500 roentgens over a few hours gives a 50% of survival. At 800 roentgens or more, survival is almost impossible. With no proper protective gear, the firefighters risked their lives to stop the fire from spreading. By 6:35, they'd put out all the external blazes. All 108 firefighters involved were airlifted to hospitals for acute radiation sickness treatment. Their skin cracked and blistered. They suffered up to 20 or 30 bloody mucus-filled bowel movements a day. A simple turn of the head would leave clumps of hair on their pillow. Of them, 28 died from acute radiation sickness within 3 months, but their sacrifice saved the nearby reactor. Yet the crisis was far from over. At the bottom of the destroyed reactor, 1,200 tons of superheated magma burned at 3,000 degrees Celsius. Countless radioactive gases and dust drifted on the wind. 15 hours after the explosion, radiation levels in Chernobyl's urban area spiked to 600,000 times the normal level. To get accurate readings at the blast site, General Plycher Gavrilov, commander of the Soviet chemical troops, led by example. In the early hours of the next day, he personally drove a lead, shielded truck into the core contamination zone. The precise radiation data he collected proved critical for subsequent rescue effort. 34 hours after the explosion, over 1,000 trucks arrived in Pripyat to evacuate residents. They were told to take only identification, essential supplies, and one toy, one child. In 3.5 hours, some 43,000 residents were fully evacuated. After the explosion, large amounts of radioactive iodine, 131, were released into the environment. The thyroid gland absorbs this isotope, and long-term exposure can cause thyroid cancer, especially risky for children. Taking iodine tablets right before or immediately after exposure can block radioactive iodine absorption, reducing cancer risk. However, the Soviet Union distributed iodine tablets too late and incompletely. This led to a significant rise in childhood thyroid cancer rates in Ukraine and Belarus in the aftermath. Meanwhile, to seal off the exposed reactor after the explosion, Soviet forces resorted to near-suicidal rescue method. Major General Nikolai Antoshkin of the Soviet Air Force took the lead, commanding top pilots in over 3,000 sorties to drop 5,000 tons of mixture. Dolomite, boron, carbide, sand, and lead powder into the reactor's opening. Dolomite released carbon dioxide to lower oxygen levels near the reactor, curbing graphite combustion. Boron, an effective neutron absorber, slowed or halted the nuclear fission chain reaction. Lead melted to cool and block radiation. Thanks to this effort, radiation levels around the plant dropped to less than 1% of their initial intensity. Some pilots flew up to 33 missions a day, braving lethal radiation doses. But the nuclear fuel kept reacting, and worse, the heat it generated sent reactor temperatures soaring. This raised fears that the concrete slab beneath the reactor would crack. Beneath that slab, a massive pool of highly radioactive wastewater had formed from the explosion's leak. If the molten core burned through the floor and hit this water, it would trigger a terrifying steam explosion instantly, flattening every city within 300 kilometers. Countless radioactive materials would then threaten all of Europe. The only solution: enter the radiation-soaked pool to install temporary pipes and drain the radioactive water. Everyone deemed this a suicide mission, yet 3 brave souls stepped forward, ready to sacrifice themselves for millions of innocents. They were Boris Baranov, Chernobyl's shift supervisor; Valery Bespalov, senior engineer of the No. 2 turbine control unit; and Alexei Anenko, senior mechanical engineer of the No. 2 reactor. Experts feared they'd die from radiation before even reaching the drain valve. But using Geiger counters and their intimate knowledge of the plant's layout, they navigated around high radiation zones and completed the mission. As predicted, the radioactive molten core later burned through the floor. Luckily, thanks to these 3 heroes, the pool's radioactive cooling water had already been drained. Still, the Soviets weren't reassured. If the molten radioactive material kept seeping downward, it would reach a vast groundwater layer near the Pripyat River, then the Dnieper, and finally the Black Sea. Radioactive contamination of these water sources would devastate drinking water and food safety across the Soviet Union and even Eastern Europe. And so thousands of miners and metro construction workers were called to Chernobyl one after another. Their task is to dig a tunnel under the reactor, to install a liquid nitrogen cooling system ready to cool down any possible lava. Inside the tunnel, oxygen was scarce. Temperatures hit 50 degrees Celsius. Miners couldn't use breathing masks, so they took off their masks, stripped off their shirts, and dug day and night without stopping. No one knows how much radiation they absorbed. 30 miners rotated every 3 hours, working around the clock. In just 15 days, they dug a 1.8 meter diameter tunnel 160 meters long. Years later, one miner, when asked about it, said someone had to do it. Either us or someone else. We did our duty. It's too late to debate if we should. All I can say is I have no regret. In the end, concrete slabs and cooling systems were installed under the reactor, stopping nuclear fuel from seeping down. The war of Chernobyl was entering its final phase. Next step is to clean up radioactive materials in the heavily contaminated areas around the plant. Then build a huge radiation-proof sarcophagus to seal reactor 4 forever. To reduce radiation exposure per person, they traded work hours for more workers. So 100,000 soldiers and 400,000 civilians, workers, engineers, nurses, doctors, scientists, came from all over the Soviet Union to Chernobyl. They were fighting the last great battle in Soviet history. Workers used heavy equipment to dig up radioactive solid waste in the 30-kilometer exclusion zone, bury it in deep trenches, and cover it with concrete. Soldiers dropped tons of sticky liquid called bubble from helicopters. This mix solidified radioactive dust into ground plaster, which civil defense teams then cleaned up house by house. The Ministry of Water built over 130 dikes before the next flood season, protecting 1,500 square kilometers of river. This stopped radioactive dust from flowing into the Pripyat River and endangering the Dnieper River basin downstream. Scientists risked their lives to drill holes outside the reactor, making sure no more explosions were possible. But building the sarcophagus hit a huge snag. It needed to go up around the reactor, but the roof and surrounding area were covered in graphite chunks from the explosion. Each chunk was highly radioactive. No one had ever worked in such high radiation. First, the Soviets tried remote-controlled robots, but in the most radioactive M zone, even the robots broke down. With no other choice, Soviet soldiers stepped in. On September 17, 1986, General Tarakonov gave a pre-mission speech. We don't know the exact words, but piecing together documentaries and records, comrades, the commissar, and I were on that roof 2 days ago. One thing's certain, there's nothing to fear up there. Our people have suffered enough from this disaster. Now it's up to us soldiers to finish this. Remember all safety rules, then shovel that waste down as fast as you can. When the alarm sounded, teams of 8 soldiers plus an officer went out. They swept radioactive debris off the roof as quickly as possible. Each soldier stayed 2 to 3 minutes, only 45 seconds when radiation spiked. One team finished, the next took over. Every soldier had a radiation detector, hit the warning level, and they were pulled out immediately. But some soldiers didn't wear detectors. They knew if they left, untrained new recruits would have to take their place. 3,828 people joined this operation, fighting particles with shovels. Months later, the cleanup finished. 3 Soviet soldiers raised the red flag of victory on the plant's highest point, just like when they raised it over the Reichstag in Berlin. In November, the sarcophagus was finally placed over Reactor 4. From afar, it looked like a giant tomb of steel and concrete. There's no denying Chernobyl's meltdown was tied to design flaws. Human error was the direct trigger. Bureaucracy's cover-up added more innocent victims. But none of that matters for the rescue hero. In this battle against radiation, 600,000 Soviets earned the Chernobyl Rescue Medal. We owe them our highest respect. Radiation detectors were scarce, so about 10% of them exceeded the 25 Roentgen limit. In 1998, the rail engine unit was phased out, just like the country those heroes once defended, now a thing of the past. In 2025, a drone carrying high explosives attacked Chernobyl. Flames erupted from the new metal shield over Reactor 4. Ukraine accused Russia of doing it. Russia accused Ukraine of staging it. We don't know who's guilty. But this plant has now become a pawn in war. And the descendants of those heroes, they might be fighting each other to the death on the land their fathers and grandfathers saved at all costs. May peace return soon. May the heroes' efforts to save humanity from nuclear radiation never be in vain. All right, that's all for this episode. If you found it somewhat interesting or helpful, feel free to follow us. That way you can learn more medical knowledge.